All right, so another definition of absolute value is units from 0. So for example, 3, the absolute value of 3 is just 3 because 3 is 3 units away from 0. 1, 2, 3. Okay. Now, if it was the absolute value of -3, well, -3 is also 3 units away from 0. So the absolute value is +3. Okay, so looking at that, if we have the absolute value of some number, we don't know what it is, it's going to have the same value, like 3, the absolute value of 3 was 3, if that number inside there is positive, so it's greater than or equal to 0. But it's going to change the sign if that number that was in there was negative. Okay, so that gives us a very formal definition of absolute value. Okay, depending on the sign of what that input is. All right, let's work on these next problems. So here I have the absolute value of 4 minus pi. Well, that we can think of as a distance problem. Pi is a little bit more than 3. It's about 3.14, so there's pi. So we're looking at the distance between those two numbers. Remember, distance is positive, but I could approximate it if I use 3.14 for pi, but let's say I wanted it to be very exact. You can't approximate pi with a decimal because pi is never ending. It's an irrational number. Okay, so to get that value in an exact form, we would need to just say it's positive. Well, who's bigger, 4 or pi? Pi is littler, right? So we need to make our answer positive, so we're going to write the larger value first. Since 4 is bigger, then we would just write it's 4 minus pi. Okay, there we go. Let's try this next one. So I'm always thinking, who's bigger? Well, 3 is a smaller number than 5 anyway, and square root of 3 is saying what times what equals 3, and that's about 1.7. That's a nice one to know. These are nice to just know, these approximations. If you don't already, I'm telling you, these are good to just memorize. Okay, so those are some approximations that'll help you understand which one is bigger. So in this one, 5 is definitely bigger. So to get a positive number here, when we look at the distance between those two, we want to write that number, that distance is positive, so we need to write the first number, the larger number first. There, we got it. 3 minus square root of 3. Perfect. Now this one's a little bit of a mystery. Okay, so we don't know exactly what the value of x is, but this is telling us that x is a number larger than 1. Okay, so when I go in and I look between x and 1, who is bigger? Well, they told me x is bigger. Okay, so that would mean the absolute value of x minus 1, which is the distance between those two values, x and 1, distance has to be positive, so I write the larger one first, and x is bigger, so I would write it as x minus 1. Okay, now you can kind of think of this also in terms of this formal definition that I have here in blue, because the absolute value of some number here, it's the same as what was inside the absolute value bars if our input is positive. And here we have a number that's positive, something bigger than 1, and 1 is positive, right? So you have the difference between those two positive numbers is positive. So you don't have to change, you don't have to write the opposite. The opposite here only happens if our input is negative. For me, it's just easier to think who's bigger, but let's look at this one. Okay, so here, who's bigger, x or 1? Well, this is our clue right here because they're telling us x is smaller than 1. So who's bigger? Well, 1. Okay, so then that means that the distance between x and 1, or the absolute value of x minus 1, would be the larger one comes first, 1 minus x. Okay, you can also use that formal definition of x, the absolute value of some input is the opposite of the input when x is negative. Okay, and if we used logic on here, the absolute value of a number smaller than 1 minus 1, so something's little and then you're subtracting 1, this is negative. Okay, so then that would be the opposite of what went in there. And then that's like distributing a -1, so negative x plus 1. And then we could use associative property, commute that 1 out to the front. Or no, I said associative, I meant commutative. Commute that 1 out to the front. And there you have it. Okay, so that's really how the book shows this. For me, I just think it's easier to think who's bigger, write your bigger number first.